Good everyone, welcome to our 2024 Skull Calc tutorial where we're going to get back into these now as we go into uni, so I've already set a few more uploads in coming times. So this is the 2024 Skull Calc exam. I actually sat this one along with the 2023 one, and it's the first time that they've done calculus such that the answer booklet, the question booklet are combined. So you see you get given a question and then just space to write your answer. That's different from previous years. I encourage you to pause the video before each question and try the question yourself before I get into it. I'm going to go rather in depth on each question, just because it is the scholarship exam. It's quite elaborate. But that being said, there are a few things that should be expected to know at this level. But yeah, let's get into it. So question one is relatively straightforward. It's a question that you know, got a function, get a stationary points in the function. We should all know how to do this at level 3. So to start with, I'm just going to copy out the equation. So we've got 3x squared minus 4x. It's 1. Oh no, it wasn't 1 minus 2, sorry. Okay, so to find the derivative of this, you're going to need to prove the product rule, which states that you differentiate the thing on top. The function on top differentiated is 4x. You multiply by the thing on the bottom. And another product rule, the quotient rule. So, and then you subtract the function on top. And you multiply by the derivative of the bottom, which should be 6x minus 4. So hopefully you can see when using how I've used the power rule, 2x squared became 4x. 3x squared became 6x and minus 4x becomes 4. Constants obviously go up to 0. And then all divided by the bottom function squared. So stationary points will occur when derivative equals 0. So you can say 0 equals 4x minus 3x squared minus 4x minus 2. Minus, now I'm actually going to expand this. So 2x squared times 6x is going to be 12x cubed. 2x squared times minus 4x is going to be minus 8x squared plus 6x minus 4. Okay, expand this out, you get 12x cubed minus 16 squared minus 8x minus 12x cubed plus 8x squared minus 6x plus 4. So this is equal to 0. Now hopefully you should recognize at this point that you're doing something right, because the 12x cubes cancel. And on summing up everything else, minus 16 plus 8 sorry, cough, is minus 8x squared, and minus 8x minus 6x is minus 14x plus 4. Now I always like to arrange this so that the coefficient of x squared is positive. So you can think of this as multiplying everything by minus 1, or just moving that side. Look, if I move this to the side, this one to the side, and the 4 to the side, look at this. Now at this point, you are totally just allowed to use a graphics calculator. So I don't have one of those emulators on my computer, unfortunately, so I'm just going to have to hand it with me. Once I type this in, you should practice typing this into your graphics calculator as well. And you should get that x equals a quarter or minus 2. Now, it does say determine the nature. Now, there isn't actually much room here. Now, typically, I just double differentiate, but that's quite difficult. So there is actually something you can do called the first derivative test. And the way it works is you say at x equals 1/4 minus 0.01. So like, this is obviously the 1/4, right? dy dx is greater than 0 at 1/4 plus 0.01 dy dx is less than 0. Now what's actually going on there is what I'm saying is just before we hit a quarter, the graph is increasing, so dy dx is positive, and just after we hit a quarter, it's decreasing. Now, I don't know whether you'd actually have to sub these in and show what the values are, but it's probably just sufficient to say this. And what this means is if it's increasing, hits the stationary point, and then decreases, it must be a maximum. That's the logic. So you could draw something like this, flat, and then down, which shows that it's a maximum. And at x equals -2, so at x equals -2 minus 0.1, it doesn't have to be 0.01, it's just be a low number. dy dx, so -2 is obviously here. And we know this is going to be a minimum. So at a little bit before it, dy dx is less than 0. And at -2 plus 0.01, dy dx is greater than 0. Therefore, a quarter, and now is where you've got to find the y coordinate, so just sub x equals a quarter back into your equation to get this 1 by squared is and -2 just setting into the calculator. That's about right. Yeah, so this first derivative test is much easier than doing the second derivative test, I'm sure you would agree. And then, yeah, so and drawing it like this, these little arrows are pretty good. Down, up and back, off at the moment. Anyway, that's the first question done. And you would get, I think from memory, looking at the answer schedule, if you get this and justified, you get 2 S marks. So 2 points there. Okay, so now part 2, we have to find a limit as x goes to infinity of the function. Now, what this essentially is saying is, as this x coordinate goes flying off into the abyss, where does our function trend to? And the problem is, when you can't just sum infinity directly, because you're going to get like infinity divided by like 3 times infinity squared. It's not doable. But the trick is to say this limit is actually the same as multiplying both the top and bottom by 1 on x squared. Now you may ask, what's the point of doing that? Because, I mean, this is essentially multiplying by 1, as long as x isn't like 0. But why, what use is this? Well, it transforms the limit to 2x squared times 1 on x squared, which is 2, and this becomes 1 on x squared, and this becomes 3 minus 4 on x minus 2 on x squared. And we can do this limit. It's just 2 plus 0 is 3 minus 0 minus 0. It's 2/3. Because when you sub infinity into 1 on squared, you just get 1 on infinity, which is 0. So it's 2/3. And another way to do this is to think, what's the highest power of x? That's x squared, and then you look at the coefficients, and in the long run it's going to run out to be just 2x squared on 3x squared, because that's the dominating factor, so 2/3 looking at the coefficients. You can also do this by the Hospital square, if you know what that is. If you don't know what that is, don't worry, because you never actually have to know. There's always a different one. Cool. And then it wants us to find the coordinates where the curve intersects its own asymptotes. Now this seems a little bit weird, right? Why would a curve intersect its asymptote? But the answer is due to the fact that the line minus the line of y equals 2/3 slides in, around about here, but it actually intersects the curve there. Now the reason for that is this graph approaches y equals 2/3 from the top in the positive quadrant up here, but over here it approaches it from the bottom. So there is actually an intersection point out there, and it's easy enough to find. You just have to set 2/3 equal to the function and solve. So as always, you can multiply across 6x squared minus 8x minus 4 equals 6x squared plus 3. I've just multiplied this denominator by this numerator and this denominator. This numerator, you'll notice the 6x squareds cancel, so we don't even have to add it. 8x equals minus 7. If you rearrange this, so x equals minus 7/8. And obviously y equals 2/3. So you can write that in a bit better notation like that. And you get both of those right. That's another 2s marks. Might be 3s marks. I'm not too sure. So that is that done. So it's just recognizing that this limit can be rewritten like this, and then 2/3. And you could say something like it never intersects horizontal asymptotes, like it's never going to intersect this thing, right? This, because the curve is undefined there. Mess of this diagram. Right. On to the first question, which is with over. What values of alpha does the following system of equations have no real solutions? So x cubed plus y cubed equals 2 and x plus y equals alpha. So the first thing I would think is, what real values of alpha the following system of equations have no real solutions? So when you want no real solutions, you typically start thinking about discriminant. But we've got a cubic, and we've got cubes, we don't really have a quadratic. But simultaneous equations, the first step should always be to rewrite one variable in terms of another. For example, y equals alpha minus x. And what this allows us to do is simply rewrite the first equation as x cubed plus alpha minus x cubed equals 2. Now, if you know Pascal's triangle, you can expand this that way, or binomial theorem. If you don't, you just have to expand it manually, and that's alright too. You're not going to get the answer wrong, as long as we're meticulous about it. So expanding these brackets, we get alpha squared minus alpha x minus x alpha, so minus 2 alpha x plus x squared. Now you may think, what am I actually doing? Well, I'm trying to solve for x, and in doing so, I should find a constraint where x is unsolvable, or at least it's not solvable for real solutions. So x cubed plus alpha cubed minus alpha squared x minus 2 alpha squared x plus 2 alpha x squared plus alpha x squared minus x cubed equals 2. Now, if you weren't following along with that, I was just taking each term, multiplying it, each term in the other bracket. Do this. So simplifying it out, then x cubed is alpha cubed minus alpha squared x minus 2 alpha squared x is minus 3 alpha squared x. 2 alpha squared plus alpha x squared is 3 alpha squared, and then we're subtracting x cubed off the end. Just 2. And very helpfully, we'll see our x cubes cancel. And so we're left with 3 alpha x squared minus 3 alpha squared x plus alpha cubed minus 2, 0. Now, if you didn't catch what went on there, I simply cancelled this, and I've moved 2 to this side. So 3 alpha squared minus 3 alpha x squared minus 3 alpha squared x is alpha cubed minus 2, 0. And this is a quadratic. Yeah? X squared got x, got a c value at the end. So, for no real solutions, we want discriminant equals, and I'm going to say this in sort of quotation marks, b squared minus 4ac less than 0. So I do hope at this level you know what the discriminant is. It's just the square root part of the quadratic formula, like x equal to negative b plus or minus squared b squared minus 4ac. And the idea is when this is less than 0, you're taking the square root of a negative number, so you get an imaginary. So this is our b value, this is our b value, this is our a value, this is our c value. So the restriction is minus 3 alpha squared minus 4 is 3 alpha less than 0. This is b squared minus 4ac. So we can write this as 9 alpha 4, it's the minus sign, doesn't matter with the square, minus 12 alpha is 2, then 0 is less than 0. So 9 alpha to the 4 minus 12 alpha to the 4 plus 24 alpha is less than 0, which gives minus 3 alpha to the 4 plus 24 alpha is less than 0. Now at this point, the best method is just to graph it, but it is nicer if you can just put it in a bit more of a factored form. So what I'm going to do is this. Yes. Yeah. So all this is saying, 3 alpha times a is 24 alpha, and 3 alpha times minus a is the minus 3. So clearly, if we graph this, there's going to be 2 solutions. There's going to be 1 at 0, and there's actually going to be 1 at 2 as well. I mean, you should be able to see that because 2 cubed is 8. This is quite an obvious bracket, 8 minus alpha cubed, that equals 0. And therefore from there we can say that that's 0. If you think about an extreme case, so for example, when alpha is really big, you're definitely going to have a negative number. So it's 3 times a really big number times 8 minus a massive number. So it's definitely going to be negative. So it's going to look like, the graph's going to look something like this. And you can just use a graphics calculator with this as well. But that's what this graph looks like. So we're looking for where this is less than 0, which is everywhere except for between 0 and 2. So there's so many different ways you can say this. The way I like is to say alpha is between minus infinity and 0. We're looking for just less than 0, not less than 1. And it's also between 2 and infinity. Now, this is where most people would stop, because you've answered it. alpha is between minus infinity and 0, it's in this area, or it's between 2 and infinity, this area. It's not between 2. The problem is, this is what you need to do to get the O mark. What happens if alpha equals 0? And the answer is, there are no solutions. The reason being that this quadratic doesn't become a quadratic, because 3 alpha x squared just becomes 0. In fact, it all just becomes 0. You get alpha cubed minus 2 equals 0, which is a disaster. And the other way to see this is you have to have x equals negative y, alpha equals 0, which would imply x cubed plus negative x cubed equals 2. So 0 equals 2 somehow. So what you really have to say is alpha is from minus infinity and including 0. That's what that box means. It means from negative infinity to 0, including 0, and not including 2 to infinity. When alpha equals 2, there is one solution to the equation, which is x and y are 1. Which makes sense, right? 1 plus 1 equals 2, 1 plus 1 equals 2. Right there, that's a real solution. So this is the final answer. I encourage you to go back and look through the working here just to make sure it's all clear, especially this little bit here, understanding this notation. You could also just write alpha is between negative infinity and including 0. You could write it in English, I'm sure they'd accept that. Anyway, this is with 2s and 1 O mark. So if you get up to here and just left, you would get 7 for the section already. But there is still one more question. Just going to leave it here for you to read. This is the hardest question in this section. It requires a few assumptions and some logic. So, let's get this building steps up one side of 48 meter height. It's the hill. This implies that height is 48. And the slope of this hill is modeled by this cubic, and A is to be determined. So there's council regulations, depth, maximum height, so on. And would all the steps support? Would all the steps satisfy maximum height regulation? Now, the first thing to do is work out what K is. And it's not always obvious how that's going to be achievable, but the way you do it is you recognize that at this point here, this must be a stationary point. So y equals 126k x squared minus k x cubed. So dy dx or y prime equals 252k x minus 3k x squared. So 0 equals 3k x minus x. Just factor this. So 3 times 84 is 252 kx. And then 3kx comes from this. Yeah. This. So x equals 84 is stationary point. X equals 0 is stationary point as well, but that's trivial. We don't really care about that. So that's all fine. And so that's stationary point. And so therefore 84, 48 is on the graph, or on the curve. Which means that if we just put 84 equals to k times, of course, 84 equals k squared times 26 minus 84, then we can look at what k is. So you can cube this and you can square this and look out and calculate it and get this. K is 1 divided by 6,174. Now that's very useful because now we have the equation. So y equals 6174 times 2 squared 126. Now, there are several different approaches from here. There is an approach which you find an equation for the size of each step by considering a y value and y plus 0.28. Considering a y value and then taking 0.28 and adding it to the x value, your equation and the difference, and that works out the height of each step. There's a better way of doing it. You can recognize that the point of inflection is at x equals 42. You can do that by double differentiating, or you can just know the fact that the inflection is halfway between two stationary points like cubic. The inflection is at x equals 42, and funnily enough, 42 meters, if you divide that by 0.28 meters, that's each step is 0.28 meters. In depth, you get 150 steps passed. So it's actually a whole number of steps. And you can say that at the point of inflection, the steps are going to be the highest because it's the steepest point of the graph, which makes logical sense. So you can say 151th step has the height of 42 plus 0.28 minus so the y value halfway up should be not x equals 40. Oh yeah, 42. The y value halfway up should be 24. So that makes sense. I'll just check that actually. 96.74 is 42 squared. So all I'm saying here is this, if we sub in 42 plus 0.28, that's the x value of the 151st step. So you take that, you sub that in and you get the height. And then you subtract the height of the 150th step, and the difference is that height between the two steps. When you work this out, you get 6174 2.28 squared 6.28. That can't be right. Yeah. Let's type in something. Yeah, you get 24.23996 times 24, which is 0.2399. Now that's greater than the 0.19, and therefore no. Yeah, and that's about it. And this question is worth 2s, and it's worth 1s and 2 marks. Yeah, it's a bit of a weird one, I will admit, but the key thing is just thinking where's the graph steepest? If that's the highest step, there it is. It turns out actually the highest step is I think the one before the building inflection, but it's we've shown there's a step higher than the building regulations, so that's sufficient. So that's where the point of inflection is. The 150 steps are passed. This is the height of the 150th step, 151st step. This is the height of the 150th step, and this is the difference. Therefore, it's the height of that step. It's too high, so that's all good. Moving on. Question 2. Need two functions f and g defined as equal. Say the max value function is defined as this. This is a lot of words, and it's a bit hard to get your head around. All it's saying is if f is greater than g, then the graph will look like f of x, and f is less than g, then graph will look like b of x. So it doesn't actually, the greater or equal sign is, it doesn't actually really matter for the context of this question, but it probably would be important to see this in the real world. All it's saying, it's always going to be the highest point. So as soon as g of x becomes lower than f of x, f of x is the leading factor here, and so on. So anyway, we've got h of x equals max of these three functions. So it's always helpful to draw. This is where you get out your graphics calculator and you put in the three functions. So we got 2 root x, 2x, and make it from the interval 0 to 3, and y value maybe 0 to 5 or so. 0 to 9. Okay, so if you draw this, you're going to recognize the three functions. Y equals root x, y equals 2x, and y equals x squared. Now, you could find the intersection. You should probably find the intersections using a bit of algebra, but you can also just use a graphics calculator. And you can say that h of x is 2 root x for that, because 2 root x intersects 2x here, and that's obviously at x equals 1. But there's not much, it's not too much difficulty in that one. You could now after 2 root x does not dominate any further, 2x is the max function. So we've got this, and then this, and then this. That's h of x. So between 1 and 2, 2x is actually the dominating function here. So you can say 2x for greater than 1, less than 2. And after it's greater than 2, the 2 is the intersection of x squared and 2x. You can find it algebraically, or you can just divide both sides by x, you get 2 equals x. And it's x squared for greater than or equal to 2, less than or equal to 3. And at this point, we've basically solved the problem. You've just taken a step back, looked at made yourself a little graph, defined the function. Is now the integral from 0 to 3 of h of x dx is the integral from 0 to 1 to root x dx plus the integral from 1 to 2 2x dx plus the integral 2 to 3 of x squared dx. And you can work out each of these individually. So 2 root x, we're going to integrate this, we're going to get 2 root x to the 1.5 divided by 3.5. We'll call root x as the same as x to the half, 1 to 0, plus x squared 2 to 1, So we integrate 2 is squared plus 2 times 3 from 2. And now it's a matter of summing in numbers. So we get, from this part here, we get 4/3. When you sub in 1, you get 2 divided by 1.5, which is 4/3. Sub in 0, you also get 0. This part here, we're going to get 4 minus 1. Sub in 2, you get 4. So 1. Subtract, definite integration. And summing in 3 here, we get 27 divided by 3 minus 8 divided by 3. And at this point, just use your calculator to work out what these things all sum to, what the fractions. You get 32 on 3. And that's the answer. And funnily enough, this was actually worth 3 yes marks. You get this right. 3 more marks. If we need 17 marks, we need 19 marks. That's worth 3 of them. Okay, cool. So this next question is worth a mark, and it's quite tricky unless you know how to implicitly differentiate. You don't know how to implicitly differentiate plus root, unless you know how to integrate uptown or 1 plus y squared. You know how to integrate that, and you might get somewhere, but it's not the easiest way of doing it. The first step, I assume you've read the question by now, the first step really is to find an expression for third derivative, starting with this. So dy dx equals 1 plus y squared. So, if we just differentiate both sides, we're going to get d2y dx squared equals, we're differentiating 1 as 0. Now differentiating y squared is going to be 2y times dy dx. Now if you don't understand that, think about, what if it was sine of x squared? Maybe that's y, sine of x squared. When you differentiate that, you go 2 sine of x, and then you multiply by the derivative of sine of x, which is cos of x. This is all we're doing over here. 2y times the derivative of y. That's just the chain rule. So that's all very well and good. This. Now at this point, you could keep it like this, or you could write this as 2y times 1 plus y squared equals 2y plus 2y cubed. So, differentiating again, d3y dx cubed equals 2y just differentiates to 2 times dy dx, and then differentiate y dx, and differentiating this, we get 6y squared times the derivative y, which is y dx. So, we have d cubed y dx squared equals, I'm going to take a 2 dy dx out as a common factor, and we're left with this. Well, this looks awfully familiar, does it not? Just make sure you understand what I've done. 2 dy dx taken out as common. So this times this is this, and this times this is this. And that's just the same as 2 times 1 plus y squared times 1 plus 3y squared. Give me this 2. Inclusive. Yep, so we're just comparing this to this. If you don't know what implicit differentiation is, I encourage you watch it. But it's just the chain rule when you don't know what y is. And then you go. But there are different methods of solving this question because it's definitely the fastest. This is funny enough, I think it's worth 1s and 1 o mark. You can do that. Okay, on to what I think is the most ambiguous and a bit strange question in the paper, but very definitely achievable. It is yes, the value question. This isn't very fun, but it's the way it is. Okay, once you define the derivative of s of 3, 5 on 2, So first off, we can write s of 3 of x is absolute value of x minus 1 plus absolute value of x minus 2 plus absolute value of x minus 3. Right. Now, there is a way you can differentiate an absolute value function. However, it's not expected that you know that. It involves square rooting something squared. But the better way to do this is to realize that S3 of x for x is greater than 2 or less than 3, greater than 3, it doesn't really matter. It actually just equals x minus 1 is x minus 2. Notice no, it's about absolute value sign minus x minus 3. But why? You might be thinking why. Well, if you've got an x value between 2 and 3, so like 2.5, which is what this is, or 2.2, 2.2 minus 1 is always going to be positive because the absolute value sign is going to be useless, it doesn't matter. Right? X minus 2 is always going to be positive. Right? If x is between 2 and 3, like 2.5 minus 2 is half. It's always going to be positive. The absolute value signs don't matter. And x minus 3 will always be a negative number. Like 2.5 minus 3 is a negative a half. So when you absolute value that, you get a half. And so therefore I put this negative sign up the front, because what that's going to do is it's going to flip this negative number to a positive number. For example, when you sub 2.5 in, you get minus a half equals a half, which is what this would give. Which means that the derivative of 2.5 equals, when you differentiate this, you're going to get x minus 1 plus x minus 2 minus x minus 3. It's actually just alright. It equals x minus 3 plus 3. If you sum all this out, which just equals x, which means that s prime 5 and 2 equals 1. You can also just graph this. Now, it should be noted that the other way of doing this is to write this. This may seem a little bit strange, but it's actually just x minus 1 on absolute value of x minus 1 plus x minus 2 absolute value of x minus 2 plus x minus 3 absolute value of x minus 3. That seems a bit strange, but that's just the way it is. It comes from considering the fact that absolute value is square root of something squared. If you sub 5 onto in here, you get 1 plus 1 minus 1, which is still 1. So it works out. Okay, next question. Find the minimum value of s of 4 of x. This is a very difficult question. Probably the second most important. I really have to take a pass at it. Because not only do you have to find the minimum value, you have to work out where the minimum value will occur. You don't actually need to justify this looking at the marking schedule, but it should be relatively clear that minimum is at 2012. Now you can ask why that is, but the general idea is that you're gonna sum all this up, and then you're essentially balancing the absolute values. Right? All of this is gonna be positive, and you're minimizing the damage. Like imagine you picked like 2024, right? It would just be all really big numbers. But 1012, you're gonna these numbers are just gonna be as small as possible. You can also graph if we graph a few smaller versions, like S of 6 of x, then you can see the minimum will occur at 3. So minimum occurs at this value. So essentially what we're trying to find is S of 2024 of 1012. Now this is tricky, right? It's 1012 minus 1 plus 1012 minus 2. How on earth do we do that? Well, the best thing to do would be to start by recognizing that the absolute values don't matter at the start, right? It's 1012 minus 1 plus 1012 minus 2 plus 1012 minus 3 until we reach 0. Plus, now we're going to start to get into the facts where it's 1011 minus 1012 plus 1010 minus 1012 and so onwards. So it's actually just 101 plus 1010 plus 1009 the 0, and the absolute value of 1011 minus 1012 is 1. Absolute value of this is 2, and that's going to keep going until we hit 0 and we get plus 1012. And so that's not that easy to see. However, it just takes a little bit of thinking. If you know that this is where the minimum occurs, it should be just a fairly safe bet. You've got to realize that the absolute values don't matter until you reach this point where the thing inside is negative. So it's just the summation of 1011 plus 1010 plus 100, so on, so on, so on, 0, and that's the summation of everything up until 1012. Here's where things get real dicey. If this is definitely an O mark question, and if you're going for this, you should know the sum of first n integers is equal to n times n plus 1 equal 2. Now that just looks like complete garbage, and I understand that point of view, but this is also an arithmetic sequence sum. So if you know the arithmetic sequences formulas, then you're going to do well there. You could also consider adding things up in pairs, but if the sum of the first n integers is this formula, so therefore we can say we've got sum of first 1011 plus sum of first 1012. This is the first 1011 numbers, this is the first 1012 numbers. Now if you sub these into the formula, you get 1011 times 1012 plus 1012 13 divided by 2, which is 1012 times 1011 plus 1013 divided by 2, which is actually just 1012 times 1012. Because if you add this and this together and divide by 2, you get their average, which is a good number in between. So the answer is 1012. So I guess you could write that out. There's something a little bit nicer. 1, 0, 2, 4, 1. And that's it. So it's tricky, but like most multi-part questions which have an O mark, it can be solved in just a few lines, but it requires some real thought. You've got to recognize that 1012 with it. The way I did that in the exam was I just tried like S of 3 of x, S of 4 of x, S of 10 of x, and just found where the minimum was. And you recognize the pattern that it's always occurring at the halfway point. It should make logical sense too. You could also argue that the derivative will be 0 at 1012 because you're going to sum up 1 plus 1 plus 1 plus 1 plus 1 1012 times and then subtract 1 1000. So that would work too. But anyway, that's question 2, and this question is worth, I think, 1 S and 2 O marks. I think 1 S if you got like this, or is that like over here? Yeah. Anyway, let's go on to question 3, which is the integration question. Find the exact value of this integral. This is not too bad, as long as you look at the formula sheet, which I'll about write down. And you recognize that cos 2 alpha is the same to cos squared x minus 1. 2 cos squared x minus 1. That's cos 2x. So we have integral 0 to pi 4. Instead of writing cos 2x, I'm going to write 2 cos squared x minus 1 and cos squared dx. And that's just equal to integral 4. If you split this up, you get 2 minus 1 squared dx. And hopefully you recognize that that is the same as 6 squared x. And so this is very easy to integrate because the derivative of tan is 6 squared. And you should be able to know that, or it is on the formula. There we go. So we've integrated, now we're going to sum our boundaries. 2 times pi over 4 is pi over 2. Tan of pi over 4 is 1. And subbing in 0 yields 0 in both cases. So that's your answer. Okay. The hard question now. Alice takes a ride at an amusement park. Involves 5 spinning teacups, circular saucers, circular rotates in a large teapot, yada yada yada. The coordinates of Alice's motion in the x-line plane can be described by these parametric equations. So we've defined where Alice is closest to the teapot. So really, the realization here is distance will just be the square root of the x squared plus y squared coordinates. Like this. This is a x coordinate, this is a y coordinate. This is the forward, that's fine. So x squared plus y squared equals that distance. I mean, you could argue you could subtract like the radius of this off, which is the closest to the teapot, not center of the teapot, but it doesn't really matter. That's all the same. So therefore, we want to minimize this. We want to minimize x squared plus y squared. That's the whole goal. Minimize this. You could minimize the square root of it, but that's just going to lead to like a bit more differentiation. All we need to minimize is what's inside the square root. So we'll call it f of theta equals x squared plus y squared. So we've got 4 cos theta plus cos 4 theta squared plus 4 sine theta plus sine 4 theta squared. Okay, if you expand this out, you get 16 cos squared theta plus 8 theta plus 4 theta plus cos squared 4 theta 16 sine squared theta plus 8 sine theta sine 4 theta plus sine squared 4 theta. So just expand this and expand this. Now here's where you're trading these two are useful. 16 cos squared theta plus 16 sine squared theta, i.e. this part and this part. It's just 16. Because cos squared theta plus sine squared theta equals 1. So you've got 16 times 1 essentially. And likewise, cos squared 4 theta plus sine squared theta, this part and this part, sum to 1 as well. If you imagine 4 theta equals theta, it's the same as this other thing. So then all we have left is this, 8 times cos theta plus 4 theta plus sine theta, sine 4 theta. Cos theta plus sine theta, sine 4 theta. Now this looks like a complete mess, but if you look at the formula sheet, you'll see something which looks like something. Where is it? Here. Notice that cosine of A plus B, or in this case, B, cosine of A minus B equals cos A plus B plus sine A sine B. Look familiar? And so therefore we can say that if A equals theta, B equals 4 theta, they are identical. So we have cosine of minus 3 theta. And that's great. So therefore f of theta equals 17 plus 8 cos minus 3 theta. And you can differentiate this easily if prime of theta equals 8 sine minus 3 theta, so theta equals pi over 3, and if you sub pi over 3 into your x and y equations, you should get 4 cosine 3 halves and 7 remaining. You should get 3 halves and 3 root 3 over 2 as the coordinates. So, yeah, that's that. You also recognize that this is just cos of 3 theta. Cosine is what we call an odd function. So cos of minus 3 theta and cos of 3 are the same. Find the distance Alice travels in one teapot. So yada 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 yada. L equals this. So really that we're going one complete revolution. So theta should range from 0 to 2 pi, and we want the square root of dx d theta squared plus, so then there's x times squared plus y times squared d theta. So what is dx d theta? Well, if it's 4 cos theta plus cos 4 theta, so we're going to differentiate that. We get minus 4 sine theta minus 4 sine 4 theta. Because remember that cos of 4 theta differentiated is minus sine of 4 theta times 4 is a rectangle. And dy d theta, differentiate this, you get 4 cos theta cos theta plus 4 cos theta. So that's all very well and good. I'm actually going to write this like this. And this. The reason being is we expanded these. Oh no, we didn't expand these before. Similar. Okay, so L equals integral from 0 to pi of square root of, well, this thing squared is just 16 times sine theta plus sine 4 theta squared plus 16 times cos theta plus cos 4 theta squared. So I've just, when you square this, you get your 16 times that. So L equals 0 pi square root of. I'm actually going to pull root 16 out. Like this. And when we expand this, we get sine squared theta plus 2 sine theta sine 4 theta plus sine 4 theta squared plus cos squared theta plus 2 cos theta plus 4 theta plus cos squared 4 theta theta. Root 16 is 4, so take that out. Now, recognize sine squared theta and cos squared theta are 1. And sine squared 4 theta plus cos squared 4 theta are 1. And then you have this. Theta. Which is all very well and good. So L equals 4 of, we take root 2 out, and we have 1 plus, now all of this, we worked that out before, that's just cos 3 theta. Do you recall from the last question that we had up here? It's cos 3 theta, or cos negative 3 theta, they're actually the same. But this still doesn't look like something we can easily integrate. And what we have to do is go back to the formula sheet and recognize that cos 2 alpha is 2 cos squared alpha minus 1. So what I'm going to do is write this as 4 root 2 So cos 2 alpha is 2 cos squared alpha minus 1. So instead of writing cos 3 theta, I'm going to write 2 cos squared 3 on 2 theta minus 1. Because if this is alpha, if this is 2 alpha, then 1 alpha is just half of it. And so what we have now is 4 root 2 integral 0 to 2 pi of the square root cos squared 1.5 theta. Because 1 minus 1 is 0. And I've taken the root 2 out. However, can't just cancel these two. Because really what this is it is 8 times integral 0 to 2 pi of the absolute value of cos of 1.5 theta d theta. And so that's a bit of a mess, but if you look at the graph of this, you'll see that it looks like it goes up and down and up and down and up and down, so on, so on, so on. And if you hit the absolute value, then you would get something like this. And it ends up being that between 0 and pi over 3, this is positive. So if we find that area and then multiply by 6, because there are six lots of this. So if you go from 0 to pi over 3, that's 1/6 of the integral. 0 to 2 pi is the full integral, 0 to pi over 3 is 1/6 of it. So if you just find this bit and then multiply it by 6, you should get the answer. So this is 48 times this integral. I'm running out of room here, but when you work it out, it ends up being, I think it's 2/3. So yeah. So I mean, hopefully you know how to integrate cosine of 1.5 theta, sine of 1.5 theta, pi over 5, and then you set your boundaries and you get this. Ran out of room there. Probably quite a hard question. Not much room to solve it. This bit is the key bit, understanding that it's not, you can't just cancel square roots, you have to take absolute value. And then recognizing that between 0 and pi over 3 it's positive. And so if you just multiply that region by 6, you get 1, 2, 3, 4, 5, 6. Just want the positive. Anyway, moving on. We've got the terrible Pythagoras question. So it's new Pythagorean theorem, apparently. Well, it's not new, right? It's just a new proof of it. Can't use Pythagorean identities, but that's all fine. The first step is, based on this diagram, to show that c squared equals 2ab sine 2 alpha. So the right hand side equals 2ab on 2 sine alpha cosine alpha, since sine 2 alpha equals 2 sine alpha cos alpha. You don't need Pythagoras to prove that. You can prove this with complex numbers, you can prove this with a diagram, you can prove it with trigonometry. You don't need Pythagoras. So right hand side equals 2ab divided by 2 times, well, sine of alpha is simply a over c, so over hypotenuse, and cosine of alpha is b over c, adjacent over hypotenuse, which is 2ab c squared on 2ab equals c squared equals the tensor. And that's that proof. I guess you have to know that this isn't a Pythagorean. It's way of doing it. Right, on to what I think is the hardest question in the paper. Oh, the last question is never mind. This is quite tough though. You need to show that u, which is this whole side here, equals this expression, and you need to also find what the v might be. It's this thing here. So what I'm going to do is I'm going to label this for a while. I'm going to label it very precisely. I'm going to call this u1, u2, u3, and I'm going to call this v1, v2, v3, and I'm going to call this z1. No, actually I'm not. I'm going to call this x1. I'm going to call this x2. I'm going to call this x3. And there's a reason I've done that. The reason is that we can say some stuff based on this diagram. I can say that tan of alpha equals x1 2a. So 2a, I've changed the line, well, second line like this. 2a tan alpha equals x1. And I can also find u1s by saying that cosine of alpha is adjacent, which is 2a, divided by u1. So u1 equals 2a cosine alpha, which is 2a, all that cosine alpha is BOC. So this is 2ac on B. That's what u1 is. Just using some simple triggers in this triangle. Right, cosine alpha equals 2a on u1, and tan of alpha equals x1 on 2a. This one is triangle here. Okay, but what about u2? Well, u2 is in this triangle here. Now, to find u2, we need to know what x2 is. And to find what x2 is, we need to know what x1 is. We do know what x1 is. We can relate this and say that tan of alpha is actually just equal to x2 and x1. So therefore, x2 equals x1 tan alpha. And you can also realize that cosine of alpha, this triangle here, equals x2 on u2. So u2 equals x2 on cosine alpha, which is BOC, so we've got x2c divided by b. So u2 equals x1 tan alpha c divided by b, which equals 2a tan squared alpha times c divided by b, which equals 2acb tan squared alpha. But you can recognize that that's actually just u1 times tan squared alpha. If you look here, u1, u2. So therefore, the ratio is tan squared alpha. Now the sum to infinity of a geometric series equals the total thing, so u, and this will equal u1 plus u2 plus u3. So u1 plus u2 plus u3, right? And it equals the first term, which is u1, divided by 1 minus the ratio, which is tan squared alpha. Just going to check. It's fine, whatever. So that means that u equals u1 is 2ac on b divided by 1 minus, now tan of alpha is a of b, 1 minus a squared over b squared, which equals 2ac on b divided by b squared minus a squared on b squared, which equals 2abc b squared minus a squared, which is what we were trying. What about v? V equals c plus v1 plus v2 plus v3 and so on. You see that from here, so it's c is plus c, and v1, v2, v3, and so on. And we've done most of the legwork here. We can see that v1 is equal to, we can use x1 or x2 here, so you could say cosine alpha equals x1 v1, so v1 equals x1. So now we have to do c, so x1, c, v. So v1 equals x1, c divided by v. We know what x1 is, it's 2a tan alpha, which is tan alpha is a of b, so 2a squared divided by b. So 2a squared divided by b squared c. So we've got b on the bottom. So we've got 2c a squared b squared. Now you can actually prove this, but you don't need to. It's logical that the ratio for v is the same as the ratio for u. It's the same ratio of similar triangles. It's the ratio of a squared on b squared, just like the ratio for u is a squared on b squared. So therefore v equals c plus the sum of all these, which is the first term, so 2c a squared b squared on 1 minus a squared b squared. This is c plus 2c a squared b squared minus a squared b squared. So c plus 2c a squared b squared minus a squared. So v equals c b squared minus c a squared plus 2c a squared by b squared minus a squared, which is c a squared plus b squared divided by a squared minus a squared. And it's just hence proven that a squared plus b squared equals c squared. There are a few ways you can do this. I've run out of room in this page, which is rather annoying. I'm going to add a page and just over some page twice. That's alright. Let's get rid of this. You can note that sine of 2 alpha should be u over v. So sine of 2 alpha equals u over v. But sine of 2 alpha is also just equal to, from this first part here, 2ab divided by c squared. U over v is simply 2abc divided by b squared minus a squared divided by v, which is c a squared plus b squared divided by b squared minus a squared. Something's not wrong. No, something hasn't been wrong, sorry. We got 2ab on a squared plus b squared is what u over v equals, but that must be equal to 2ab on c squared, and therefore a squared plus b squared must equal c squared. That's the final proof. So it's just about finding the ratios. I'm going to try being a bit clear on that. I should go back and slip through it slowly. It's not quite clear. So on to question 4. So all the complex numbers that satisfy all of the forms of functions. So we've got this, and this. If the argument is between minus pi over 3 and pi over 3, then it's going to look something this. Pi over 3. Z plus z bar less than 4 is something x plus iy plus x minus iy is less than or equal to 4. So 2x is less than or equal to x is less than or equal to 2. So essentially that's that, and absolute value of z is greater than 2. So modulus is greater than 2, so x squared plus y squared is greater than 4. So that means if we draw a circle with radius 2, then this has to be greater. So it's everything which is not in the circle is this locus, right? Everything not in the circle. Not in the circle. But it's got to be less than 2, it's got to be within these lines. So really, the applicable region is this bit here. So we have to find that area. Now, this line here, the lines are y equals tan pi over 3x. The gradient must be tan of the angle. Now tan pi over 3 is, I think it's root 3. Yeah. So root 3x. So at x equals 2, y equals 2 root 3. So this is 2 root 3, yeah? And this will be minus 2 root 3. So the triangle area is half base times height. Now the base is 4 root 3. It's just this length, right? And then the height is 2. So you got 4 root 3 as the triangle area. And then we want to simply subtract the circle area. Now, the circle area will be pi r squared. Pi r squared is 5 times 2 squared is 4 times the ratio of this part of the circle, or circle, which will be 2 pi over 3 out of 2 pi. So that this is the sector. It's 2 pi over 3 angles out of a total 2 pi. So we've got 4 pi times the third, because this sector is only 1/3 of the circle. So 4/3 pi. So the total area is the area of the triangle minus the area of the circle inside that. And there we go. We got some proofs now. Z equals cos theta plus I sin theta with the following. I'm going to start with the left hand side. I'm going to show that this is 1 minus sin theta equals 1 divided by 1 minus cos squared theta minus I cos theta sin theta. Now 1 minus cos squared theta is sin squared theta. And I'm going to factor out a sin theta at this point. So I literally just subbed in Z, expanded it, and I recognize that that is sin squared theta. So I'm going to sub that something I need is sin theta minus I cos theta. Yeah. And at this point, you have to conjugate. So we have sin theta minus cos theta, and then times it by its conjugate, which is sin theta plus I cos theta, sin theta plus theta, and that's 1 on sin theta times sin theta plus cos theta on sin squared theta plus cos squared theta, which is 1. And that's sin theta plus I cos theta divided by sin theta, which equals 1 plus I. So the sin theta divided by sin theta is 1, and sin theta divided by sin. Okay, 2 argument z plus 1 equals argument z. This is tricky. You can use tan inverse laws, but the way I find this easiest is to use geometry for this. I may consider z, it's cos theta plus I sin theta, which means it's on the unit circle, like it has modulus of 1. Consider z and z plus 1. So this can be okay. Now, this is z. This is z plus 1. I've represented them as diagrammatically. We'll call this alpha, and we'll call this beta. So we can say that argument of z plus 1 is equal to alpha, and the argument of z is equal to alpha plus beta. Okay, which should make sense. But recall that modulus of z equals 1, which means this is 1, and this must be 1 because it's just the difference between x plus 1 and x, which means this is an isosceles triangle. So isosceles triangle, therefore base angles are equal. So what does this mean? It means that it means that alpha must equal beta. So if you look at this diagram, they are opposite angles. Opposite angles between parallel lines. This line, this line. So we're bringing out the inner geometry. A simplified version is just to look at this. That's beta, that's alpha, they are the same angle. So alpha equals beta. So that's really interesting, which means that argument of z actually just equals 2 alpha, which equals 2 argument of z plus 1, which is what we're trying to prove. Okay. The point 2 pp is on some point in the line y equals half x. So the locus of points the same distance in p as the line 2. So parabola is locus of points that exist exists the same distance from focus point, which in this case will be 2p and directrix line, which in this case is half x. All that's saying is if you plot this on the graph, that's going to look like this. Sorry, oh yes, all of that. Oops. All that's saying is that distance there, not really looking to scale, but that distance there and that distance there should be equal. Yeah, so the key features are this is the focus and this is the directrix. That's pretty much it. This is the hardest question on the no doubt. Another point Q on the line y is minus 2x, there it is. Less than 0. So R is the regional clusters, but locus of points that are 3 times as far from P as they are. So P and Q are moving along their respective lines. P is increasing at a rate of 3 centimeters per second, and Q decreasing at a rate of 2 centimeters per second. At what rate is the area of region R? So this is tough, but we first need to define the locus. So they're 3 times as far from P as they are from Q. Imagine this was a complex plane, and what we would say is the distance that the point is from Q are 3 times as far from P. So like, what does this mean? Yeah, okay. So distance to Q is -2Q, that 3 lots of that is the distance to P. So the locus of points is the locus of all points Z in the convex plane that are 3 times, if you take the distance to Q, this distance here, and you multiply it by 3, the distance to P, this distance here. So 3 times as far away as they are. So they're much closer to Q. So this is a locus. It's not the easiest one in the world to work out. But it should look like this. Hopefully you're familiar with modulus. Okay, that's what it looks like. So you've got to square both sides. We're trying to find an equation, something reasonable like this. You square both sides and you get 9 times x minus q squared plus 9 times y plus 2q squared equals x minus 2p squared plus minus p squared. This is a circle. We need to find its radius. So we got 9 times q squared minus 2qx plus q squared plus 9 times y squared plus 4qy plus 4q squared is equal to x squared minus 4px plus 4p squared plus y squared plus 2py plus p squared. Which leads us to 9 x squared plus y squared minus 18qx plus 9q squared plus 36qy plus 36q squared equals x squared plus y squared minus 4px plus 4p squared minus 2py plus p squared. So this, I'll get it all out. Because we can now group like terms. So 8x squared plus y squared. We have x with 4p minus 18q as our x term. So on y term we have 36q plus 2p, and as the constant term this all equals 5p squared minus 36q squared. 645. Okay, I'm just rearranging. Now, to put a circle in, we need to find the radius of the circle, which is still quite a task. I'm going to divide everything by 8. E squared plus y squared equals x times half p minus 912 cubed plus y times the 36 divided by 8 is 18 divided by 4. 912 cubed plus p, and this equals 5p squared minus 3 times squared divided by 8. Now, to find the raise the circle, we have to put the circle in x minus h squared plus y minus a squared equals r squared form. So we have to complete the square. So when we do that, so we say x plus 4p minus 9 4q squared minus 4p minus 4 squared. This is just this term, it's x squared plus. When you have, just to explain this in another way, you have x squared plus 3x. You want to write this in bracket form, it's x plus b on 2 squared minus b on 2 squared. This is actually how you put your quadratic formula. The reasoning for that is if you square this, if you multiply this out with x squared plus 2 times b on 2 plus b squared on 4 minus b squared on 4, which is just b squared plus b. That's all I've done. So halved this b term, so we've got a quarter and 5/4. Just tracking that off. Why don't we do the same thing for y now? Let's go. Plus y plus 9/4q plus 9/3 minus 9/4q plus 9/3 squared, and that equals 5q squared. 5. Now at this point, we found the radius. Radius squared equal to 5p squared minus 3 on 8 plus 4p plus 9/4p squared plus 9/4p. Right. Good. We don't actually care about the center of the circle, so we pointless. We just care about these terms which are summarized in the radius. So, r squared equals b squared plus 16 b squared minus 18 16 q plus 81 16 q squared plus 81 16 q squared plus this is pretty tedious 18 32 plus 1 16 q squared is expanded to 2 brackets. So this turns yeah, okay. So now we can go to our terms. After the p squareds, that's 5/8 plus 16 plus 64. We have 45 to 64. Squared, we do have 2 squares, we have minus 45/8. 31 16. p's we have minus 18, 6, 2. A little bit worth somewhere. Did I do? No. No, it's fine. Okay. So the area of the region of the circle is pi r squared. This is pi times the waste garbage. Now we want the rate to time. Differentiating time. We get following. This is implicit differentiation again. So 45 64 p squared and 2 down to get 90. 45. 90 64 p to the pdt plus 18 to pdt minus 9 16ths. This is quite difficult. dp dtq p times dq dt. That's the product rule in action. Which first multiply by the second. It's the same multiply by the second. Okay, we're going to use this with that, but that's fine. dAdt at q equals minus 4. P equals P equals 3. And this equals pi times right. 90 64th times 3 times dp dt. dp dt is just 3 plus 9 times q, which is minus 4 times dq dt. dt is minus 2. Minus 2. And we want minus 9 16ths of dp dt times q. So that's minus 12. And p times dq dt is 3 times minus 2 plus 6. Simplify this out a bit. Is 432 now minus 72. This could have gone wrong. Why is it good? I have the wrong answer. That's interesting. Do with the marks people. Bottom. That's very interesting. They don't have a QP term. They just have 45 64 p squared. Not that. That's right. This is these two are not right. Something's gone wrong. And I'll be honest, if someone can point it out in the comments, that'd be quite useful. I don't want to go through and redo this. Was my original locus correct? Is this the problem? Distance of q is right. X minus 2p squared plus 1 minus p squared. Yeah, equals times x minus q squared plus y plus q. Yeah, okay, so it's maybe algebra x under somewhere, unfortunately. I don't know where it is. That's not right. This is all done. Last. Yeah, I need to make I do the version of the guys. This is kind of a disaster. But, oh well, aside from the last bit's been sort of fun. I will just look at the last schedule this morning. I'll just leave it there, just pause if you want to look through that. I think so just give it a pause if you want to have a look at that. Maybe I will look at this later and try to work out that. Anyway, that's that. This is not the answer more of that. Somehow, yeah, somehow it's just gone quite well. Oh well, that's the fumbles. See you guys later.